Guys, Coach Moss here. Welcome back. This is going to be Unit 7 over graphing the trig functions. That is cosine, sine, tangent. We're also going to have secant, cosecant, and cotangent. But I'm going to do one short video over this one and one over the other just because this is going to take me a little bit of time. I'm also going to show you how this makes sense according to the unit circle as well. So we're going to start with cosine. And what I'm going to start by doing is filling out this chart. Now, for our measure here, we are going to use 0. We're going to use pi over 2, pi, 3 pi over 2, and then 2 pi. And what I can tell you is these are all measures here, and why we are measuring by these is because on the unit circle, this is what we're measuring by. 0, pi over 2, pi, 3 pi over 2, and then once we come back around, this will be 2 pi. All right, so since we're talking about cosine, cosine is on the unit circle is always represented by the x value of that coordinate. So at 0, the x value is 1. At pi over 2, our x value is 0. At pi, our x value is -1. At 3 pi over 2, our x value is 0. And back at 2 pi, the x value is 1. All right, so now we're going to graph it. We have 0, 1. Okay, we have pi over 2, which is at 0. And then at pi, we have -1. 3 pi over 2, we have 0. At 2 pi, we have 1. And as you can tell, it will continue to just go here. So same thing. I'm just going to kind of reflect it over because it'll be the same if we were to keep going. There we go. All right, and as you connect these dots, it definitely looks a lot more wavy in normal pictures, but because of graphing purposes, it's just going to look a little more sharp here, but it definitely curves better than that. All right, so the domain of this function, of course, that means what x values are included. This is a continuation. This is only what we're showing, but really these will continue. So all x values are included because it just continues to go across. So domain is -infinity to infinity. And our range, as you can tell, so it's going to stay exactly like this. It is never going to go below -1 or above +1. And then as far as special features go, we are going to write that it is an even function. All right. And then from there, we'll move on to the next. Now, these are just the basics of each. We're going to get more in depth of knowing different features about them as we go, but this is just a starting point. So sine is going to be the same. We're going to be looking at the unit circle, but we're going to be looking at the y coordinate. So I'm going to be using the same coordinates here, 3 pi over 2 and 2 pi. All right, so the y's are what I'm going to write here. So at 0, our y is 0. At pi over 2, our y value is 1. Pi, our y value is 0. 3 pi over 2, we have -1. And at 2 pi, back at 0. All right, so as you can tell, this one is completely the opposite of cosine. So it's going to look very similar. 0, 0. At pi over 2, we have 1. At pi, back at 0. And then down to -1, up to 0, positive 1. All right, and that is our graph for sine. So when talking about the domain and range here, for sine, our domain is the same. It continues to go from negative infinity to positive infinity because all x values are included. And again, our range is going to be the same because the graphs are basically the same. One is just shifted over just a little bit. And then as far as special features go for sine is an odd function. Now, in case you're not remembering how to know if it's even or odd, you need to know basically if it crosses through the origin, you can look just here. If it is symmetrical about the origin, as in if I were to rotate this, it would be the same. If we were to rotate this over here, we could like rotate it around the origin and it would be symmetrical. That means it's an odd function. If it is symmetrical about the axis here, then it's even. All right, we've got